get into it. Alright, so this is the task we're looking at today. Let's see what it's all about, first of all.
Given two strings, find the number of common characters between them.
Great. Okay, so we're talking about strings today. Now, if you recall, strings are basically just words, or a way of representing words in a programming language, specifically in this case JavaScript. And so since we're going to be working with strings and characters and stuff like that, I mean, we've done a lot of tasks up to this point where we've done some comparisons and stuff like that using numbers. But since this one's all about strings, I want to introduce this concept of ASCII codes. Now, if you've used the internet before, you've probably at least encountered this concept. So this is an ASCII table right here. ASCII, again, I don't know if I'm pronouncing that right. That's usually just the way I say it, but it stands for American Standard Code for Information Interchange. So it's just sort of like a standard way of representing numbers as, representing letters as numbers. I guess it works in the other direction as well, vice versa. But the main thing is that, you know, there are lots of situations where we might want to do this, maybe as a way of comparing characters more easily, maybe like as a way of doing a cipher or something like that, if you want to encode a message, if you want to encrypt it. So, I mean, there's going to be lots of uses for this sort of thing, but this is the main thing. I mean, basically, if you're looking at how to read this, if we wanted to represent a lowercase a as a number, well, the ASCII code for that is 97. Let's say we wanted to encode a capital F. Well, that's 70. So we can interchange between these. We can sort of represent a character as a letter or a number, a string or a number, and we can convert between the two, and that's basically what we're going to do today. So since we're going to be working with strings, we'll look at some of the built-ins that JavaScript has for us that allows us to interchange between the two. So just as a quick example, let's say we're looking at, let's let str just be this kind of sample string, and it's going to say, hey, what's up? That's going to be our sample string. All right, so str, and let's just say we want to return str, and then here's our first built-in. So we're going to do dot character code at, and then we're going to give this an index, just like as though we were talking about an array or something like that. So str.characterCodeAt, let's go with 2. Okay, we'll see what that gives us. So with character code at 2, we're getting 121. So if we want to know what's the significance of that, let's take a look at our ASCII table, and we'll look for 121. There's 121, so that should be a lowercase y. Okay, so lowercase y, character code 2, yeah, it's a lowercase y. Remember, the indices here are the same as an array, so we start with 0, then 1, then 2. Okay, so that is index 2 there. So our character code at index 2, in this case, is 121 because it's y, lowercase y specifically. We could look at a different one. We could do character code at 0 or character code at, how long is this thing? Let's try 10. See which one 10 is. 32. Ooh, that's a low one. Let's see what 32 is. Oh, that's the space. Okay, so even a space character does have a character code. Now, basically what we're seeing here is the argument is the index. What we're using as the argument is going to be the index that we're trying to find the character code at. But what if we don't give it an argument? So let's see what happens when we run it that way. It's giving us a number still. This is giving us 104. If we look up our table, 104 was that lowercase h. So there were 2 lowercase h's, but if I had to take a guess, I'd say it's probably this one here. We're not giving it an argument, so by default, it's giving us the 0th element, the 0th index character here. That's the code it's giving us. Okay, so basically, if we don't give it an argument, then it'll just give us the first character. Well, why would we want that? Actually, it's kind of common because a lot of the time when we're dealing with these things, we're talking about kind of like one character strings, in which case, you know, it'd be kind of redundant to put in the index at 0 because that's the only index there. So that's kind of a convenient way of doing that. And like we saw earlier, 97 is the ASCII code for lowercase a. All right, so that's pretty nice. I mean, that's a useful little tool we can be using. And we can also do something like this. We could say let num be assigned the value of, let's say, 106. Okay, and then instead of doing character code at, we have another built-in. This built-in is a method within the string object, so we're going to do capital S string and then dot from character code, and then we'll just use num as our argument in this case. So num is 106. Now we're converting that to j. 106 is j. Okay, there we go. All right, so it works both ways, and we can sort of do that to get some kind of neat effects. Like, for example, we could do a function, let's call it next character, and it's going to take in a character. That's going to be the argument. And so when I say a character, I mean some languages actually make distinctions between these, but in JavaScript, as far as I understand anyway, a character is basically just a string of length 1. So we don't really make a distinction between a single character and a whole string of characters. All right, so we want the next character. We're going to give this function a character, and basically what it's going to do is it'll say let code be assigned the value of character. I'll just move that out of the way. CharacterCodeAt. And since we're talking about a single character here, we're not going to put in an argument. It's just going to be CharacterCodeAt because there's only one index to be spoken of. It would be redundant to actually put that in there. If you prefer putting in the 0, you can, but I don't think it's really that necessary. Okay, so I'm going to say let next be assigned the value of string.characterCodeAt, and we'll do code plus 1, and then we'll just return next. Okay, so now this is our function next character. Let's see if it works. So let's say return next character, and what do we want to use as a first one? Let's go with p, and we'll run that. What are we expecting to get from that? Well, if it's the next character, oh yeah, I used the wrong thing here. It's not CharacterCodeAt, it's from character code. Silly me. All right, let's try that again. So we should expect Q. There we go. So from P to Q, we started with P. It's basically converting that to 112. It's adding 1 to 112 to make it 113. It's converting it back into a string. It becomes Q, and that's what we're getting back. So that's kind of a neat little function that we can use. That's just sort of an illustrative example of why we might want to actually work with ASCII codes and do these from character code and stuff like that. Because if we were to try to do something like this instead, let's say P and then just plus 1. Okay, so we're just adding 1 to P. Well, this might have kind of an unexpected behavior, and this will work differently in other languages, but here it's just P1. Now, the reason behind that is something extremely subtle, and it can be a bit of a gotcha for a lot of newcomers to JavaScript. The plus sign is context dependent, and this is super, super important. Okay, so this doesn't always mean addition. So in a case like this, if we were to do, return like 1 plus 3, let's say, well, that's going to give us 4 because it's adding 1 and 3 together. Okay, gives us 4, it's adding 1 and 3. But if I was to do, let's say, the string 1 plus the string 3, well, now it's not addition. We call this operation concatenation. So adding strings is not actually addition. It's concatenating, which means putting one right after the other, putting them together as one string. So keep that in mind. We can do this with whatever string we want. Cool dude. There we go. So we put those together and it should be one word. Okay, but then we might wonder, well, what happens if we sort of mix these things? So let's say 5 plus the number 3. Let's see what happens there. 53, and keep in mind it's in a string. All right, let's switch that up. So we'll say number 5 plus the string 3. And we're still getting that 53 here. So basically the idea is that when it sees that you're trying to add a string, it's typecasting. It's saying, oh, well, that's a string. We can't really add a string to a number, so they must be talking about concatenation. So as much as possible, we don't want to leave it up to the JavaScript engine to sort of try to decide what we meant by this. So if we want this to be a number, then let's make it a number. Let's do a little parse int on this thing, parse int, string 3, and that should give us the 8 that we're looking for, because it's basically saying, okay, well, that's a number. This is also a number. We'll add them together. Something I should probably mention is there are other ways of doing this. Like, for example, we could just do 1 times the string 3. If we're trying to multiply a string by a number, well, there's no multiplication operation for strings, whereas there is, like, what I'm trying to say is the plus, it can mean addition if you're talking about numbers, or it can mean concatenation if you're talking about strings. Whereas the asterisk here, it only means multiplication. It doesn't have a special meaning for strings, which means that there's no ambiguity about this. It knows, oh, wow, if you're multiplying these, you must mean that you want to use 3 the number and not 3 the string. Okay, so that's kind of a hacky way of doing it, you know, the 1 times 3. I probably don't recommend that just because, I mean, I know it saves bytes and all that, it's good for code golfing, but again, we want to be clear to the reader. That's always a big goal for us. So parse int is a nicer way to do that. It's a little more in line with the syntax we'd see in other languages, and it just sort of makes a little more sense than 1 times 3. You know, someone might look at that and think, like, well, why are you multiplying it by 1? That's not going to change the value. So lots of reasons why we might want to do it this way. Okay, so we've talked about concatenation versus addition. We've talked about fromCharacterCode. We've talked about charCodeAt, so we can convert between numbers and letters now. Now, one last thing I guess I want to say about this is, what if we're looking at this and saying, well, you know, it's kind of nice that we have this standard, and keep in mind this is not just JavaScript. Like this is an international thing. This is like it's very, very general is what I'm trying to say. Anyway, so it's nice that we sort of have that established standard, but at the same time there's maybe some issues with it, right? Like, what if we didn't want a to be 97? Or lowercase a, I should say. What if we didn't want lowercase a to be 97? What if we wanted to represent lowercase a as 0, represent lowercase b as 1, c as 2, d as 3, etc., right? If we wanted to do that, well, we can do that. That's definitely possible. We just have to subtract 97. I mean, as soon as we have this number, it's just like a number. We can work with it just like any other number. So we could just do something like, you know, return, well, okay, I kind of like to do it this way, just to make it, again, as clear as possible to the reader. So let's say, let character be assigned the value of p, something like that. And let's say we wanted to know the character code of this guy, but not in terms of the actual ASCII number, just in terms of how far it was down the list here. So actually, maybe I should have chosen here. Let's go with D, because we know that it should be index 3 if we're going 0, 1, 2, 3. I don't have to count all the way to P, so let's go with D. Okay, so basically, with what we're about to do, what we want is for this to return 3. So the way I usually like to do this is this. So we have our variable .characterCodeAt, and from there, we could just do minus 97, and that would work because we know that that 97 is, and yeah, we are getting 3, we know that 97 is the character code for lowercase a, so we're subtracting that. But again, just to make it very, very clear to the reader what we're trying to do, I actually do tend to do it this way, a.characterCodeAt. And, you know, you could argue, well, that's hindering your computation time because it means you're doing another one of these character code lookups. And that's a fair point. That's, yeah, I can't argue with that. Yeah, I suppose another way to do it would be to actually make a constant. So we could say const lowercase a code or something like that, and we just do a.characterCodeAt, or we could even do like just make it equal to 97. It's whatever. But the main thing is I'm using a const for that instead of a let, because it's not something that's going to be changing. It's always going to be 97. It's not like we're going to reassign this value. So that's why we're using a const here. That's the nice advantage of a const. And by the way, just to sort of demonstrate that feature of a const, if we tried to make this something else, like let's say maybe the character code for B. Let's say we tried to assign it to that. Well, it's going to have an issue with that. It's going to say, hey, you're trying to do an assignment to a constant variable? You can't do that. You had your one chance to do that up here. You can't do it again. Oh, and by the way, when I say you had your one chance to do it up here, like we have to assign it. You know, we can't just let this happen later. Like it doesn't know what to do with this. We can't just declare a constant without actually assigning it a value. Whereas something like this would be totally fine. We can have this. Oh, and I should probably get rid of that. We can have this, you know. Well, yeah, I guess it's still going to have an issue because it's not assigned here. So I guess let's assign it. So we'll say character is. Let's go with P now, and there we go. It works. It doesn't have any issues. Okay, so I guess it's the 15th letter. Anyway, point is, we're going to be using all of these tools today for at least one of the methods that we'll use for this problem. So at this point, I think we're probably ready to dive in. Let's get this started. Okay, so first things first, conceptualizing the problem. What are we looking at here? We're trying to find the number of common characters between two strings. So in other words, the number of characters that appear in both of them with repetition included. They maybe should have mentioned that in the explanation, but it's clear from the examples. So if we look at the first example given, so we've got, or I guess the only example given, we've got these two strings. And we want to know how many characters do they have in common. So going through, looks like this one's got 2 A's, a B, and 2 C's. This one's got, I guess, 3 A's total, a D, and a C. So basically, if this one has 2 A's, this one has 3 A's, that means they've got at least 2 A's, and well, they have exactly 2 A's in common. This one has a B. This one doesn't have any B, so no B's in common. This one has 2 C's. This one has 1 C, so 1 C in common, and this is the only one with D, so no D's in common. Okay, so basically that means they had 2 A's and a C in common, which is why our answer here is 3. So again, just like some of the previous challenges, we're not looking to actually say what the common characters are, but we just want to know how many of them are there. Okay, so that's basically our goal here. And if you think about it, we could do it just kind of the way we just ran through this. You know, we're looking at these and we could say, well, how many A's do we have in this one versus how many A's do we have in this one? How many B's are in this one? How many B's are in this one? And then we'll basically just take the minimum of each of those. You know, so like for example, this one had 2 A's. 2 A's. This one had a total of 3 A's. So minimum between 2 and 3, it's 2. So there are 2 common characters there. Okay, so that's basically going to be our game plan. So we're going to count the frequency of each character for each of the strings. And then after that, we're going to, I guess, tally up the minimum from each character. Minimum frequency for each character. I don't know what's the better wording here, but anyway, that's basically our goal. Okay, so we want to count the frequency of each character for each of the strings. I think the best way to do that would be to do an array. And again, there's going to be a few ways we can do that. So let's say we'll do freq1 for the first frequency, and it's going to be an empty array to begin with, and freq2 is also going to be an empty array. All right, so the way we're going to do this is, at least for now, we'll basically we'll make a loop. Let I be assigned the value 0, I is less than 26, I plus plus. So I is going from 0 to 26. If you want to take a guess at that 26, you're probably right. It's the number of letters in the alphabet. And keep in mind, these are lowercase. It doesn't say it in the description above, but it does say it down here. So, I mean, I guess we should always read this whole thing. And also, while we're down here, notice the guaranteed constraints. It's not too bad. Like these aren't going to be super long strings or anything like that, so we probably won't have to worry too much about our time complexity here, but it's something that should always be in our mind, right? Okay, so let's see. All right, basically for every character, we want to say, well, how many times did this character occur in the first string? And then how many times did it occur in the second string? And we'll sort of push those to our frequency numbers here. So we could say something like, all right, so our first character is going to be, let's do it this way. Let character be assigned the value of string dot from character code. And we'll do I plus a dot character code at. Okay, just like we were talking about before. So that's going to be our character. And then let's count the characters for each of the arrays. So basically, we'll do, for frequency 1, well, okay, hold on. Before we go any further, how are we going to count the frequencies here? Well, we could loop through the string and say, hey, are you equal to character? You are? Okay, great. Let's increment by 1. Are you equal to character? Yeah? Okay, increment again. Are you equal to the character? No? Oh, okay. Move on to the next one. Are you equal to character? No? Okay, maybe the next one. No. Are you equal to character? No. All right. So we end there. So we could do something like that. Loop through. At that point, we're getting into nested loops or something like that, and it could get kind of complicated. So I'm actually going to go right to the sort of more functional approach to this. And I'm going to use some of those array built-ins that we've been looking at. So I'm going to say s1 dot split. Now we've talked about split before, but just to remind you, this is something that's going to take a string and turn it into an array. So actually, you know what? Let's just comment that out for a minute, and just right up here, let's just say return s1 dot split, and we're using an empty string as our argument here because that's the thing that we want to split it at. So for every empty string we find, and technically it's counting an empty string in between each character, so basically it's just splitting the whole thing apart. A, B, C, C. Well, that's the same as string 1, same order as string 1, except now it's being represented as an array. Why do we want to do that? Great question. Well, it's because with an array, we get new tools. We have built-ins that we can use. So we could do something like this. We could say, let's do a filter. Right? So a filter, as you recall, this is a function that's going to run on every element on the array, and it's going to return a Boolean, so a true or false value. If that Boolean has a value of true for the given entry, it'll keep that in the array. If it has a value of false for the element, it will not keep that element. So basically, we just want something that's going to say it's a function, it's going to take an input of x, and it's going to have an output, which is our Boolean, that's going to say x is the same as character. That's basically it. So if you're equal to this character, if you are the same as, in this case, lowercase a for the first iteration, lowercase b for the second iteration, etc., then it's going to keep that inside this array. But the thing is, well, actually, hold on a sec. Let's just do a quick console.log just to see if this is working. And very important, we should probably spell console right. There we go. All right, so let's try running this, and we'll see if that works. Okay, great. So that's working the way we want it to. I mean, for the A's, it's just keeping the A's that were in string 1. For the B's, it's keeping the B's that were in string 1. And for the C's, it's keeping the C's that were in there. And then for everything else, just empty array, empty array, empty array. Because, you know, there weren't any D's, there weren't any E's, F's, etc. Okay, but the thing is, we don't actually want to have this whole array here, right? Because we don't care about which ones are actually common characters. We care about how many of them are there. So after the dot filter here, we're going to do something that's just going to count how many there are in the array. This is a nice thing about filter. We don't actually have to use this array. We can just do a dot length on it. And this is a pretty cool way of basically just counting up how many times that string occurs in, or that character occurs in the string. So 2 A's, 1 B, 2 C's. So now this array, that's like a bunch of integers, mostly 0, that's an equivalent way of representing the characters in this string. It's not quite equivalent to the string itself because the order is not clear. You know, like even if we scrambled this word up, we would still have the same output as long as we're not changing any of the letters to something else. As long as we're just rearranging them, that's fine. Okay, so we'll keep that in mind because that's actually going to be sort of a key fact for this problem. But the main thing is this is giving us our frequency for character at index I. So what we can actually do is something like frequency1 dot push this thing. So we could do that, and then let's say at the end we'll just return frequency1, and we'll see what we get from that. So remember, dot push basically just takes a number or any kind of element and puts it at the end of the array. So basically, we put in the 2, put in the 1, put in the 2, and then a whole bunch of zeros. And there are 26 elements here. If you don't believe me, I mean, we could do a dot length on this thing, and it should give us 26. So there we go. All right, so that's frequency 1. Now we basically want to do the exact same thing for frequency 2, like pretty much the exact same thing. So let's do that. Frequency 2 dot push, and that's going to be s2 dot split dot filter, all that kind of stuff. Okay, so let's see if that works for frequency 2. It should work exactly the same. There's no real difference. Okay, great. So we have 3 A's, no B's, 1 C, 1 D, exactly what the doctor ordered here. So that's working great. Okay, so we've got frequency 1, we've got frequency 2. Now we just need to do this. Tally up the minimum frequency for each character. All right, so let's maybe say, I might as well declare this other variable at the top here because that's kind of a nice place for it. Let commons be assigned the value 0. So commons, that's how many common characters. We could call the variable common characters or I don't know, something else, but commons is probably good enough for what we're trying to do here. So tally up the minimum frequency for each character. Well, basically the way I'm going to do that is I'm going to loop again. Oh, not var. Let's use an I. Let I be assigned the value of 0. I is less than 26 once again, and I plus plus. Let's give that a try. And basically, I'm using 26 because I know frequency 1 and frequency 2 are going to have a length of 26 because it's just one for each character. And then I'm going to say commons plus equals. I'm going to add to whatever commons was, and it's starting at 0. I'm going to add to it the minimum out of these two. So I'm going to say math.min frequency 1 at I and frequency 2 at I. Okay, and we could do something like that. And oh, I guess I should probably return commons here. Is it what we're looking for? It's what we're looking for. So take a look at that. That feels good. All the check marks. Let's take a moment to soak that in. Okay, great. That felt good. So now let's continue here. I want to make this better. I want to improve it because really, like, this is pretty sloppy code. And I'm saying that for a few reasons. There are some really, really sloppy elements here. So, okay. First thing I want to address is right now, as it's going through this loop, every time it goes through, for every character, it's taking S1 and it's splitting it into an array. It's doing the same thing for S2. It's doing that every single time it iterates through this loop, and that's too much. Converting a string into an array is something that could take a very long time. I mean, that's basically, if we had very, very long strings here, well, that's not something we'd want to have to keep repeating. So let's just do something like this. We'll say let A1 be assigned the value of S1 dot split. And we'll let A2 be assigned the value of S2 dot split. Okay, now that's a little nicer both because it means we're not actually repeating that calculation as much, and also because this is getting a little nicer, a little more compact. It's not as gross. So let's run that. Okay, pretty nice. So that's an improvement, both in terms of computation time and in terms of the readability of it, I would say. But now this thing, I mean, look, we're doing the exact same thing to both of these. We're doing a1.filter with this function .length. So let's make a function for that. Actually, this is something I've been meaning to talk about because a lot of people ask me, you know, when do I want to use a function? Like, what's the right time to be using a function? And really the simplest answer to that is when you don't want to repeat yourself. So if we find that we're in a situation where we're doing the same exact thing more than once, then we can make a function to do that for us. So we could say something like, I guess I'll put my function, I'll put it way up here, right at the top. And it's going to be called, well, let's give it a good name. What are we actually doing here? We're counting the character frequency. So let's say count freq, and what is the input going to be? Well, it's going to be a character. So let's say char for character. So there we go. And what do we want to be returning? Actually, is there... okay. We need more than just that, right? Because this is also something that's different, A1 and A2. So let's do R and char. So array and character. And then basically the idea is we want to return array.filter, and then this function here, x gets mapped to the Boolean that says, is it equal to the character? And specifically, we want the length of it. So we could do something like this and switch this over to count freq, and I guess we need to give it some arguments. So A1 as the first argument, and then, well, char, the character that we're actually using down here. Okay, and then I'm going to copy that over to this, change that to an A2, and let's see if that's going to work just as well. It's still working. Okay, but I'm starting to get a little conflicted here, because at this point we're going through this loop and we're calling up this function, and then we're calling it up again, and we're feeding it both the array and the character. And I feel like maybe there's a better way to do that. So this would be a good time to talk about scoping, I guess. So we've talked a little bit about scoping before. It's basically this thing where if you want to grab a variable that's either within a function or within some other block like a loop or an if, then that's where let is basically scoping these variables inside the block. So like if I was trying to get if I was trying to get character down here, return char, it's going to say, what are you talking about? It's not defined. And I'm thinking, well, isn't it defined right up there? And this is the difference again between let and var. Var would actually let me get that and say, yeah, it's set, because that's the last thing it would have had. But we want to use a let here because we want to make this secure. We don't want any memory leaks, so we want to scope to the block as much as possible. So that means character is only available within this block here, inside this for loop. So what I'm going to do is I'm going to try this. What if we were to take our function and actually put it inside our for loop here? And so now it knows what character is, so I'm going to not feed it that as an input. I'm just going to say array. And since I'm not feeding it that input, let's just get rid of that second input. So let's see if this works now, because it's within the scope of the for. Still works. Okay, so is that better? I don't know. Hard to say. I mean, there might be a problem with sort of declaring this function every time the loop is going through. So, yeah, hard to say. That might be counterproductive. Okay, so let's see if there's a way we could maybe get this better. Well, one thing to note is we're kind of like storing up all these frequencies, and then after that, we're going through the array again and saying, what's the minimum? But the thing is, we have both frequencies up here. We could just find the minimum at that point, right? We don't really need to do that. So we could, instead of doing this freq1 business and all that, we could just say commons plus equals math.min. I mean, the same thing we're doing downstairs here, except we'll just grab these things. So we'll say count frequency A1 and count frequency A2. There we go. And then we don't need to worry about these freaks.push. I think we probably won't even need to worry about that. And we can take this comment and reappropriate it to here. So let's see. And I guess at that point we don't need these either. Let's see if this works. Will this work? It works. Okay, so that's pretty nice. That's pretty nice. Can we make it any better? Well, yeah, we can make it a little bit better. And, well, actually, okay, we can do it differently anyway. I don't know if this is better, but it's a way we can do things with ES6 that's maybe a little strange. But, okay, the first thing here is we've got two lets. We're saying let A1 be this, let A2 be this. But first of all, since they're both lets, I can actually just sort of get rid of this one and line this up, make that a comma. And that should work pretty much the same way. It's basically saying let this be that and let that be that. Okay, but if we wanted to make it even more efficient, notice we're basically doing the same thing for each of these. So we could do something kind of like this. Let, and then in array, A1, A2 be assigned the value of S1, S2. And I'm going to do the same function to them, so I'm going to map them to this. And that should do the same thing as what we had up here. So let's see if that still works. Hey, it still works. Okay, so is this better? Questionable. I mean, in terms of human readability, I'd say maybe not. It might confuse the reader to see this in an array because we're actually not using this array at all. You know, like this array is only being used to assign, well, and to declare and to assign these two new variables, A1 and A2. Now, what I don't know about this is how it works in terms of memory, because this array is, well, we're not giving it a name. We're not going to be using it later on. So that sort of leads me to believe that it's going to get garbage collected and that we're not going to have to worry about the memory usage there. But if anyone has a more definitive answer on that, hey, I'd love to hear it. Okay, so let's move this down a little bit because it's probably more appropriate to be over there. Where were we? Okay, there we go. And now it kind of all fits. Yeah, all fits on the screen. So let's run the tests. And there we go. So is there anything else we want to do before we submit it? That's probably good for now. Let's try that. See if it actually passes all the tests. Oh, and it does. And you know what else? Boom, look at that. We made it to a new level. Congrats, everyone. Okay, so let's get that out of the way. We're not done here. We want to do some other stuff. So the first thing I want to talk about here is basically, okay, look at this. We've got this for loop, and we might say, well, this for loop is very nice because it's only going from 0 to 26, guaranteed. It will not go beyond 26. So that's kind of nice. But then when we think about what it's actually doing, because it's doing this filter on A1 and A2, because it's basically going through the whole string here and the whole string here, it has to do that 26 times. That could get pretty heavy. I mean, basically the advantage to doing the 26 here is if the strings were really long. Let's pretend it didn't have this constraint. Let's make a little edit here. Let's say, no, they're not 15. They can go as much as 10 to the power 5 and 10 to the power 5. Okay, so now if this is the case, we probably wouldn't actually get away with using this algorithm here. I think this would basically time out and we would have, well, we wouldn't pass the tests and everyone would be very sad. Okay, so basically we want to avoid that. We want to be in a situation where we don't have to worry so much about the time limit exceeding. We want to do things more efficiently if possible. And so the way we're going to do that is we're not going to use this 26 thing. Because, yeah, like I was saying, the advantage to the 26 is, well, what if the strings were really long? Then we wouldn't have to worry about the loop going that far. But we'd have to worry way more about it because the filter has to go through that whole, 10 to the power 5 or whatever it is. And it has to do that, what, 52 times? Because 26 for A1, 26 for A2. You have to do that 52 times. That's way too many times. So let's see if we can make this a little more efficient. And we can. So basically the way we'll do it is we'll just say let, oh, okay. So let's see, what are we looking at here? Yeah, okay, we're going to do this differently. So we're going to say let char of A1 Boom. Okay, so now we don't need to say what the character is because it's actually just going to get the character from A1. And we'll have this count frequency business over here. Are we going to still do that? No, we're not going to do that anymore. Okay, so we're going to do this a bit differently. Instead, we're going to say for the first character of A1, and let's, you know what, I'm just going to scrap this actually. We're going to start over because we're going to go back to doing this. Freak1 as empty array, and let freak2 be an empty array as well. But actually, now I don't want them to be empty arrays. I want them to be filled arrays. I want them to be arrays that start out with 26 elements. So I'm going to do this trick that we've seen before, new array with 26 elements. And not only have we seen this trick before, but we've seen some of the tricks this can pull on us, in the sense that, you know, if we wanted to do like return freak1 first of all, it's going to have kind of a strange answer for us. So it's going to say no, 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 no. And I guess that makes sense because none of these have been assigned yet. So we could say like, okay, well, yeah, freak1 at 3. I guess it makes sense that this would be a null or an undefined or something like that. So in that case, let's just let's assign it. So we'll say freak1 at 3 is assigned the value of, I don't know, 2 or something like that. And then, okay, so it's stored in there. And if we take a look at freak1, let's see how that was working. Okay, so we got null, 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 and then 2 over there. But there are some drawbacks to this. So like, for example, we could say for x of, what was that, freak1. So we're doing a for loop, and I'm just going to say console.log x. So let's just take a look at what's inside the array to begin with. Okay, we got a bunch of undefined, so it is looping through here. This is probably good enough for what we want. Or is it? Well, we want all of these to be zeros. So, okay, how about this? Let's do that that trick that we found. So I think it was like this: dot fill 0, and we'll make this dot fill 0, and we'll see what we get from that. Okay, that's what we're looking for. So no need to worry about anything aside from that. We'll just use dot fill. All right, so we've got freak1 and freak2. They're both this. I mean, we could do this differently if we wanted to. You know, we could make it like it's assigned the value of frequency 1, but we'd have to put a dot slice in it. Or another way, I don't know if I've mentioned yet, but this is another way to do a deep copy of an array. So these should still be the same thing now. So if we were to run this, now, yeah, it's still just all zeros. And importantly, if we were to change frequency 1 at a certain value to something else, let's say, that shouldn't affect frequency 2, so we should still get an array of all zeros here, which we are getting. So that's good. That's good to know. Let's move on from there. Okay, so we've got our frequencies. We know that those are basically just arrays of all zeros, and we're going to return something else at the end, which is going to be commons, which we haven't defined yet. So commons assign the value of 0. So this is looking a bit like the algorithm we had before, a little bit different because we're actually filling the array with stuff instead of starting them as empty. Okay, so what are we going to do here? Well, let's see. We were doing something like this before, where we were saying character of A1. And at that point, we had A1 defined. We were saying A1 is basically S1 dot split. Okay, so we could do something like that for, and let me just pop a let in front of the character there just to scope it to this block over here. And then we could just do something like, we'll do a console.log of the character. Okay, so there we go. We're seeing each character that's in the string. Nice. Okay, but let's say we didn't want to do a split. Let's say we just wanted to loop through S1. So the question is, does this of loop work just as well for something that's a string, for something that hasn't been actually split into an array? Is it going to understand all the elements the same way? Well, as it turns out, yeah, it works. Now, is this proper? Is this something that we should be doing with the string? Well, that I couldn't really tell you. I'm not sure. And if anyone knows, again, fill me in. I'd love to hear it. Okay, but for now, we know what the character is. So let's just say this. Let code be assigned the value of character.characterCodeAt. And I got to type the whole thing because I haven't used it yet here. So code is character.characterCodeAt. Okay, great. And then we could do something like freak1 at, oh, actually, you know what else? We don't actually want to just use this because we basically want it to normalize these. So I'm going to do -97, or I guess just to be consistent, I'll say a dot character code. Dot character code at. There we go. So that's our code, and then we'll say freak1 at code plus plus. You know, whatever you found there, whatever that was. Like if it was lowercase a, that'll get normalized to a 0 because of the minus we're doing here. So it'll say the 0th element. Add 1 to that. It was 0 to begin with, and that's actually why we're doing this and making all these 0 instead of undefined. I mean, there are other ways we could deal with that, but I found this convenient. So we'll say frequency 1 at our code plus plus. And then let's see what it comes up with at the end of this. So let's say just return frequency 1, see what we're getting in that array. Oh, look at that. It's looking the way it did before. 2, 1, 2. Okay, so that's nice. That's very nice, actually, because notice I didn't have to loop through 0 to 26 and every time do a filter, basically loop through the whole array every time. I'm not repeating that traversal of the string here. In fact, we didn't even convert it to an array. We're basically just going through the string and saying, okay, what's the code at that thing? And, you know, even it, look, if we wanted to get more efficient about it, we could even do something like this. Just like that, you know, look up the code, subtract the code from A, plus it, and, you know, it's one line, so we don't really need to do anything more complicated than this. We're running through it, we're doing the same thing. Is there any other way we could do this? Well, you know, we could do a dot map or something like that, but the thing is, at that point, we actually would have to split it. We would have to convert it to an array. So I think this is probably fine for our purposes, and then we'll just do the same thing for S2. So we'll just say S2 there, character of S2, and that's going to be frequency 2 that we're going to be changing in that case, but everything else should be exactly the same. So we'll run the tests on that. And yeah, there we go. That's what we were expecting again, because there were 3 A's, no B's, 1 C, and 1 D in the second string there. So now we could do the same thing we had before. So we could say for let I be assigned the value of 0, I is less than 26, I plus plus, and commons plus equals math.min of frequency 1 at I and frequency 2 at I. So we're basically just looping through the 26 then and just saying, hey, what was the minimum number for each of these characters, because that's how many they have in common. And so there we go. That, I think, is a better algorithm. Like, by a lot, I would say. So I like this a lot better than what we had before. Let's submit this just to make sure it's working for the whole thing. And there we go. Okay, so that's kind of nice. Now, let's see, is there any other way we could do it? Well, yeah, for sure. And in fact, this is kind of an interesting opportunity. We've talked about dot map before. So if we were to do something like return frequency1.map, and let's not run that, let's return that. Frequency1.map, and I don't know, what do we want to do? Just increase the value by 1? Something like that. I don't know. Just basically the same thing, except now we've added 1 to all of our values. Not too interesting. So now instead of just x, we're actually going to take a second argument, which I'm calling I. What's I? Well, let's find out. Let's just return I and see what we're getting. So it looks like we're getting the index 0, 1, 2, 3, 4, 5, 6, all the way up to 25, because 0 to 25, there are 26 elements. Okay, so I is the index that we're looking at. So why am I doing this? Well, I basically want to do something like this. I want to map from frequency 1, I want to do a math.min between the current value, which is x, and that same corresponding value in the other array. So freak2 at I, so whatever it has at the same index. So now if we do this, that's going to give us an array of all the common characters. So we have 2 A's in common, we have 1 C in common, and that's it. That's why there were 3. And notice if we add these up, we would get 3. And we can sort of look at some of these other ones, say 1 plus 1 plus 1, that's also 3. There's 0 in that case. There's only 1 in that one. For this one, there were 4 that were the same. So, okay, our examples are not the best here, but this looks like it should work as long as we just add up all the values inside the array. So the 2 plus the 0 plus the 1 plus the 0 plus the 0, etc. How do we do that? Well, you guys already know it's reduce. It's something we've seen before. So we're going to just keep this going, dot reduce, and it's a function that's going to take A and B and return A plus B. Now, I've done a couple videos already that explain how reduce works, so you can review those if you need to, or let me know if you have any questions about it. But this should, since it's reducing this all down and it's just going to add up all the numbers here, this should work without the stuff down here. So if we run this, that's it. That's all we need. Okay, so is this better? Is this better than what we had on the screen a minute ago? Well, let's just undelete that for a sec. This is doing a dot map, so that means it's going through the first frequency array. So it would basically have to go 26 times, just like this loop down here. It's doing a math.min between the two elements, so just like this one over here. It's looking both of them up, but then after it does all that, it does the reduce, as opposed to the way we're doing it down here, which is basically just storing one element in memory and just adding on to it each time. So the reduce would traverse the array again. Now, since we know the array is going to have length 26, that's constant time. It actually doesn't really matter that much, but it's not just the computation time or the time complexity or even the memory optimization that we need to worry about. It's the human readability too. And I mean, when we get into these kind of like chained together maps and reduces and stuff like that, it's going to make sense to people who are familiar with them, but I think this is just a little easier on the eyes. It's just a little easier to see what's going on with this. So, whether you want to do it like this, or whether you want to do it, I guess, like this, actually, because we wouldn't need the comments. So, yeah, that's a little more terse. The other way is a little more clear, I would say. It's sort of up to you. So, it's your call. Any suggestions? I don't know. I think, just for human readability purposes, I'm going to leave it like the way we had it. So, like this. Okay, so we'll have that, and I'm going to comment that out, because we're going to look at our second method here at this point. So, that was pretty good. I think this is a good algorithm. I think it makes a lot of sense. It's inoffensive. It's pretty clear. But we're going to try a totally different method now. So I'm actually just going to make some space, and we'll just do something very, very different. So in terms of what we want to do here, well, let's look at another illustrative example. Oh, let's start drawing. Okay, so we'll look at another illustrative example here. And basically, it's going to be 2 strings and... Okay, well, the method that I want to talk about here is going to touch on something that we mentioned already, which is that the order of these strings doesn't matter. It doesn't matter what order these strings are in. So, this one could be like BACAC or something like that. It wouldn't be any different from this. It still has the same frequency of all of its characters. So by switching around the order, we're not actually changing anything. So that's what I want to start with for this one. I want to start by arrange the strings in ascending order of character code. I guess I could say ASCII code as well. Yeah, let's do that. ASCII code. That's what we're talking about after all. ASCII table. Anyway, the point is we're going to arrange the strings in ascending order of ASCII code. So why are we doing that? Well, I'll explain why we're doing that with an illustrative example. So let's look at two two strings here, so we'll say S1 and S2. What are they going to be? So S1 is going to be this string that's A, B, E, E. I'm going to put it just in order right off the bat here, because it's going to get to that order anyway once we arrange it. So let's just start with that. And then the other one is going to be B, B, B. I'll try to line them up vertically as much as possible here. C, D, F, F, F. So strings don't have to be the same length. Yeah, they definitely don't. We saw a test where they're different. Yeah, okay. So this is fine. They don't have to be the same length. So what are we going to do this time? Why have we arranged these in order? Well, there's kind of a neat thing that we can do with this. So I'm going to take two iterators this time. I'm going to have one called I and one called J. And basically the idea is that I is going to start at 0, going to be pointing to the first element here, and J is going to also start at 0 and be pointing to the same element here. And then basically we're going to run a loop that's going to last until we get to the end of one of these strings, or both, but as long as we're at the end of one of them, that's enough to end the loop. So let's get that in our comments here. So loop until the end of at least one of the strings. And what are we going to do in the loop? Well, let's talk about that now. So basically the way the loop is going to work is it's going to say, okay, are these the same string? No, they're not. So which one has the lower character code? Well, in this case, A would have the lower character code. This one's 97, this one's 98. So while this one has the lower character code, move it up. Move up the index, I++. Does it still have a lower character code? Yeah, it does. So move it up again. So it's going to go to B. And now, are they the same? So basically, once we get to the end of that loop, and that loop is going to iterate I until S1 character is no longer less than S2 character. And I'll just use CHAR so that we don't spill over into the next line, because that was a little sloppy. Okay, so are they the same? If they're the same, we'll iterate our counter, our tally thing. So I'll just say, hey, there's one. There's one that's the same. Okay, and then as soon as we do that, once there's one, once they are the same, we'll move both of these up. So we'll do a J++ and we'll do an I++. Okay, so let's put that in there. Are they the same? And if so, increment I, J, and counter. Or we were calling it commons before, so let's be consistent with that. Okay, great. So now we're on to these two. We're comparing these two. So is the character code of E less than the character code of B? No, it isn't. So we won't do anything at that point. Is the character code of B less than the character code of E? Well, yeah, it is. So we'll iterate until that's no longer the case. Okay, so now we're comparing B and E again. This one's still less, so we'll iterate. Now E and C, this one's still less, so we'll iterate again. E and D, this one's still less, so we'll keep iterating. Now it's going to be F. We'll say, okay, are they the same? Nope, they're not the same. So we're not going to increment this. We're not going to count another one. We're not going to tally another one on. We're not going to move on from here. We're not going to move on to the next letters. We're going to repeat the outer loop, which is basically going to return with us iterating I. So now we'll say, okay, is E less than F? Is the character code of E less than character code of F? Yeah, it is less. So we'll increment that. Is this character code less than this one? It still is, so we'll increment that. Is it still less? No, it isn't, so we'll stop there. And then we ask ourselves, okay, is this one, does this have a character code that's less than this one? No, it doesn't. They're the same. So since they're the same, we'll count another one, and we'll increment onto the next elements. Okay, so now we say, all right, well, does H, we'll go on to the next iteration of the loop, we'll say, does H have a character code that's less than F? No? Okay, so then does F have a character code that's less than H? Yes, it does. So we'll move on to the next one. Still less, we'll move on to the next one. Oh, looks like we reached the end here, so we're done. We're gonna close the loop at that point, and we find our final answer is 2. There we go. Okay, so let's do that now. Let's build that out. Okay, so first we want to arrange the strings in ascending order of ASCII code. So that's the part that's maybe going to be a little bit weird. We'll do a function for that because we want to run this on both of these strings. So we'll say function arrange characters. Kind of a long name for a function, but we want it to make sense to the reader. So arrange characters, str. And what are we going to do with str? So, okay, I'm going to say let array be assigned the value of str dot split. There we go. And then we'll just do, I guess, array dot sort, arr dot sort. And that's it. We don't actually need to give it like a sorting function. We saw before the last time we used sort, we were doing it with numbers, and so we actually had to give it an argument that was a function that told it how to sort the numbers, like under what circumstances do we want to switch them, under what circumstances do we want to keep them the same. So we're not going to have to worry about that now because by default it's going to be a lexicographic ordering. So in other words, the same order we're used to seeing in like in the dictionary or something like that. Okay, so array.sort, and I guess what we want to do is just return array.join. There we go. So that's going to give us a word that should be in ascending order here. So let's try that. So we'll do return, what was it? Arrange characters of S2, because S1 in the first test is already arranged, so it wouldn't look any different. That's what we want, AAACD instead of ADCAA. So keep in mind, the frequency of the characters is exactly the same here and here, but the reason we want it in order is because that's the only way this algorithm is going to work, because it basically iterates until one of them is no longer less than the other one. So, you know, if we tried to do that same algorithm over here, we'd say like, oh, okay, well, I guess there's no A's left in this one, so let's keep moving on, and then we get surprised by the A's at the end there, and it would just be a very negative situation, and it would break the algorithm. Everyone would be very unhappy. So we're not going to do it that way. All right, but we can tell that this is working. So let's see. I guess let's do this. Let's say let A1 and A2. We'll just do this declaration and assignment the way we had it before, S1, S2, except I like this a little better because now our map, we can, well, okay, let me do this one step at a time. We could say X is getting mapped to arrange characters at X. Okay, so that, and now it's not A1 and A2 for array 1 and array 2, it's for arranged 1 and arranged 2. Okay, so then we can say return A2, and we'll see if that's working. So just like before, the way we had it, we're mapping this, it's working. We're basically saying X is getting mapped to the output of arranged characters at X. But here's the thing, I mean, like this map, it's looking for a function that takes 1 or, like we saw earlier, 2 arguments, and then it's going to output this thing over here. Well, arrange characters is the same sort of function. It takes one thing in and it gives one thing out. So let's just actually say arrange characters. That's going to be our argument here. And that should work exactly the same way without any difficulties. And even if we wanted to, like, we're only using arrange characters right here. So like, we could even just say something like, oh, X gets mapped to X dot split dot sort dot join, and even that should work the same way. And it does. So what's better? I don't know. What do you guys like better? It's up to you. But I guess I'll just stick with the way we had it before, just again for human readability, because it's not going to make any difference whether the function's declared up here or whether we just put it in there. I mean, in terms of human readability, it'll make a difference. So let's do it that way for now. But you know, it's up to you. So we want to loop until at least one of the strings, until the end of one of the strings. Okay, so let's do that. How do we do that? Well, we could do a for loop, and I think that would make sense because we've got I and j that we both want to be starting at 0. So notice I'm using that comma trick we saw before. And we want to make sure that I is less than a1.length and j is less than a2.length. Okay, now the and here. Why is it an and not an or? Well, basically we want to repeat this until one of them is no longer the case, right? Like if I gets too big, we should stop. And if j gets too big, we should stop. So basically as soon as one of these things is untrue, we should basically make the whole thing untrue. As opposed to like if we were to use an or in here, then it would keep going until both of them are at the end. And that's not what we want, because once we've reached the end of one of them, it's not going to have any more common characters with the other strings. It's just not possible. It doesn't have any more strings to go through. Now, what are we going to do at the end here? Well, I don't really want to put an I++ or a J++ at the end, because if you think about it, the circumstance under which we iterated I and iterated J, those were not just happening at the end of this loop every time. So I'm actually just going to leave that blank now. And I need my other variable. I need commons. I don't think I've declared that yet. So, okay, we assigned commons. That's great. We want to iterate I until S1 character is no longer less than S2 character. Okay, so we're going to do another loop in here. We're going to put a little while loop in here. And our while loop, well, there are a few ways we could do this. So we could say while a1.characterCodeAt I is less than a2.characterCodeAt j. And then while that's the case, well, I don't need a whole line for that. It's just an I++, so I'll just put it in there. So while this is the case, we'll say I++. Keep I going. Keep iterating it. But, you know, .characterCodeAt I, a2.characterCodeAt j, well, we don't need to do it that way. I mean, we don't need to actually convert them into numbers in order to actually compare them. Like, just to give you a very quick example, return A is less than Z. Should this be true or false? Well, A is less than Z, so it's true. Is A less than capital A, on the other hand? No, that's not true, because if you think about their character codes, 97 versus 65, 97 is not less than 65, so that's why we're getting a false there. So we can compare these. And also, another thing I should mention, because I don't know if I have yet, but let's say str is, how's it going? Something like that, right? We could return string dot character code at 3, let's say. You know, we could do something like that. But let's say we don't want that 39. Let's say we want the actual character, not just the character code. So let's do character at 3. Okay, so it's the apostrophe. But we could treat it more like an array and actually just say string with the index of 3. We're getting the same thing. And we can compare characters, strings, without having to convert them to numbers. So we're going to combine both those facts over here. So we're just going to say a1 at I is less than a2 at j. There we go. And under that circumstance, we're going to increment I for as long as that's the case. But only if it doesn't take us to the end of the string. You know, we don't want to go overboard here. So let's also say that I has to be less than a1.length. I is less than a1.length. And that also needs to be true. Okay, great. So then at that point, that'll go as long as it can, and then we basically want to do the other thing. You know, we want to say, well, let's iterate this one until it gets to be at least as big as the other one, and then after that, let's iterate this one until it's at least as big as the other one. That should basically keep going until they end up being the same, or they miss each other, right? So like first we found it incremented this one all the way up to B, and these were the same. So this was the first match that we had. And then after that, it moved on to the next ones, and it found that it had to increment the b until it got to actually all the way to f, because it compared b to e, b to e, c to e, d to e, and then finally f. And so this one overshot it. It went too far. So then this one was f. This one then needed to start incrementing until it reached f. So we could have like a mismatch. They might miss each other. But we ultimately want to do this same thing, but kind of the other way. So we'll iterate j until the s2 character is no longer less than the s1 character. And basically, you know, you might be wondering, like, well, shouldn't we just stop after this one, right? Like, what if they ended up being the same? Like in this first case, we incremented this until they were the same, and we found, well, we didn't have to go any further. So why bother with this second loop? Well, it's a good question. The reason we would bother with the second loop, and the reason it's not going to make a difference, is because, well, now the character code of b is not less than the character code of this b over here. They are the same, so it's just not going to fire that loop. So this is worth doing. Okay, and it's the other way around now, right? If a2 at j is less than a1 at I, then we want to increment j. Okay, and we're comparing this to a2, not a1. So keep in mind, there can be some dangers in copy pasting. There are advantages to copy pasting. I mean, it keeps all of our variable names accurate and stuff like that. But you know, the disadvantage is in case we miss something like that. So watch out. I mean, do copy paste, but do so with caution. Are they the same? So the question is, well, at this point, if a1 at I equals a2 at j, then under that circumstance, we basically want to say, yes, we found a common one, so let's increment that. And let's just move on to the next ones, because we've counted that common one. We're not going to compare it to something else. So we're incrementing all of these, and I'll just put this up here, because it's all being taken care of right there. All right, I guess I could have put it like inside. It's fine. All right, so there we go. And that should close off our big for loop, I think. Wait a sec. I never even opened it. So that's the issue. Let's get that downstairs. Boom. Okay. Looking good. All right. So how's this? This is good, I think. Is anything missing? Well, we haven't tested it yet, so let's give it a test. Let's see what it's going to do. Oh, look at that. Okay. It passes the sample tests. All right, well, that's good. So then, well, let's see. Is there anything left to say about this? Is it going to pass all the tests? Is it going to pass all the hidden tests? Let's try submitting it and see if there's maybe a hidden test that it's going to trip up on. No, there isn't. Okay, so this worked just fine. There are no problems here. Now, one thing that I thought might have been a problem is I thought that, you know, if this were to iterate too far and actually get to the point where I is a1.length, I thought that might sort of cause a crash. So it could be that that's not happening. It could also be just that that's not covered in the tests. That's not something we have to worry about. Either way, it passed. But if we did want to build in like a security measure for that, then we could just say something like if I is equal to a1.length at this point, then break. You know, just get out of the loop, because we know at that point that you're at the end of that first string. So we could run it like that, and I don't think it's going to make any difference. So like I said, I'm not sure if that's a test coverage issue or if that's just not something we have to worry about. But the reason I'm mentioning it, just in case anyone's wondering, is because of this right here. Because notice, after this first loop, we're then going and comparing a1 at I to a2 at j. So if we're actually asking it what's a1 at I, it just kind of feels to me like we better be sure that it actually exists. So that's why we'd want to do this thing, you know, if it's within the range of a1. Okay, so basically this means, just to remind you about break, if this ends up being the case, it's not going to execute anything down here, and it's not even going to go to the next iteration of the loop. It's just going to break right out of this loop. So this loop is done as soon as it sees the keyword break. All right, I do kind of like having this security measure in here, just I don't know, it's a safety thing, just in case. So I'm going to leave that in. And okay, just to sort of close the loop on this task, what's the better method? So we've got two of them here. This first one I really like because, or when I say first one, I'm talking the top one here. So this one that we're looking at, the one that's currently illuminated, I like it. I think it's really nice because we're only looping through each of the strings at most once. You know, as soon as we get to the end of one of the strings, we're done. And you know, you might be looking at this and say, why, yeah, but look, you've got nested loops, man. You've got a for, you've got a while, you've got another while, you've got two conditionals, and there's so much stuff going on. Yeah, that's true, but keep in mind, like, this isn't a for loop that's looping through the entire string or anything like this. This is just a for loop that's basically just telling it to keep going and keep comparing these things until I and j are at the end. So really, think about it this way. This for loop and these two while loops are iterating through each of these strings. The while loops are the ones actually moving along I and j. The for loop is basically keeping that process going. So it's doing it in parts. So the for loop is basically the thing that's making these while loops keep executing even after they find a common character. Or like I said, if there's like a mismatch or something like that. So, okay. So that's nice. I mean, I really like this algorithm. I really like the way it does this basically a single loop through both of the strings. So again, you know, if we're looking at a situation where the strings are just out of control and super large or something like that, this would be nice because it just loops through each of them once. But the problem here is that we're doing the sorting at the beginning. So that means we're at least iterating through it a whole nother time for each of our strings at the beginning. So at that point, it gets a little tougher to weigh the two against each other. In this case, we're basically just dealing with arrays of length 26. We are looping through each of the strings once, and then we're looping through the 26 character array. This will happen in, you know, big O of n, where n is the length of the strings, or, you know, big O of n plus m, where n and m are the length of the two strings respectively. Whereas this will happen in big O of 1. I mean, you could say, well, wouldn't that be like big O of 26? But that's the thing about big O notation. I mean, you basically round it down, so to speak. We don't worry about constant multiples, so 26, it's a constant. You know, it's not going to get bigger or smaller than that, so we consider that the same as big O of 1. Whereas these would actually increase in complexity if the strings were longer, so that's why they're more like big O of n, or, you know, again, it's a linear thing, so we don't have to worry about like, oh, well, wouldn't that be like big O of 2n plus 1? No, it's big O of n. We're looking more just at the sort of the degree, like what the underlying function is, what the parent function is. Anyway, okay, which of these is better? Oh, this is shorter code. This one is longer, but I'd argue maybe nicer to look at. Here, let's just see the whole thing. Can it fit? Oh, just. All right, so there we go. Yeah, it's hard to say. I don't know. I would say I kind of prefer this one because I think it's neat. I think the way the algorithm is running is kind of cool and exciting. But, you know, that's just me. I mean, maybe you prefer this one down here. It's up to you. Either way, this is going to be on the solution. Let's just submit to make sure it's the same. And yeah, okay, it's still correct. So both of them run. I mean, it's up to you which one you prefer. So click on this here if you want to see these, copy, paste them, all that kind of stuff. And as usual, I mean, let me know if you have any questions, comments, or concerns.